view we're starting off with is factoring. So we have to factor polynomial expressions is what the curriculum states that we have to do. So we're going to go through different types of factoring, remind you what you did last year. Factoring is a huge outcome that if you can't do it in 11 and you can't do it in 12, you will not be very successful. So if you're someone who's like, I got through last year without knowing how to do it, it's going to halt here. It's going to start getting ugly. Okay? And you use factoring a lot in grade 12. You're going to do factoring with trig. So like sine squared x plus sine x minus 2. And you have to factor trig. You will have to do polynomials where you're going to have to do degree 4s, and you'll have to do synthetic division, and end with factoring. So factoring pops up in a lot. And anytime you're asked to find any type of x-intercepts, most of the time you're going to have to use factoring. So it's huge in grade 12. So if you're still bucking on the system of not wanting to do it or learn it, today's the day where you want to realize that that's not a good thing to do. Okay. So 3x plus 12. Greatest common factor, we can take out a 3. And then we're left with x plus 6, or x plus 4. That's some bad math. So what you have to remember with factoring is the very first thing you always want to check is, can I take something out of it? Out of every term. If it's 2 terms, there's only 2 things you can do. So if there's 2 terms, just like this one, there's only 2 things you can do. You can take out a greatest common factor or difference of squares. So that's what you look for when you have 2. That's the only things you can do when you have 2. So this one doesn't have a difference sign even in between. It doesn't have a subtraction sign, so it's for sure just a GCF. The second one, can we take anything out of it? Out of all 3 terms? You can take out a 2. When we take that number out, it just sits out in front. It's like our leading coefficient. So take a 2 out of all of our terms, and we're left with 3x squared plus x minus 6. Blanked for a second. Okay. So when you go to factor it, you have to ask yourselves, what times what equals the first times the last. This 2 will just travel its way down the whole time. It doesn't affect it at all. However, the 2 is important for changing your y-intercept because it does make a difference. By that common 2 coming out front actually doesn't affect your x-intercepts. It's just a number being multiplied by it. So we leave that 2 out front, and then we say what times what gets me 3 times negative 6, so negative 18, and what plus what equals the middle term, so 1, plus 1. Is there anything I can multiply to get me negative 18 and add to get me 1? Well, think 18. 18 and 1? No. And if it's negative 18, I need to have 1 be positive and 1 be negative, right? 9 and 2? No. 6 and 3? No. Anything else for 18? No. So this is as good as it gets. Sometimes all you can do is take out a GCF and you're done. Can't go any further. It's not possible. If 90% of the time you're saying it's not possible, you're probably not right. But sometimes it will happen where you can't take anything out. Okay, next page. So now we have product sum. So that's when you have a 1 in front. When you have a 1 in front, you can instantly go to the double brackets. But only when you have a 1 in front. If you have another number in front, you have to do decomp. Unless you can take that number out of all the terms and end up with a 1 in front. Then you could go back to product sum. So I always hazard people who maybe it's been a while that you factored, or maybe you just found it really hard, to always do what times what equals 1 times 12, so 12. What plus what equals 7. So I know it needs to be a positive 12, so I know my signs need to be the same. So they either need to be positive, positive, or negative, negative, right? I have a plus 7, so they need to be positive, positive. So I always do my signs first. Then I say, what factors of 12 lead me to being added to 7? 12 and 1? No, that's 13. 6 and 2? No, that's 8. 3 and 4? Yeah, that's 7. Does it matter if I go 3 and 4 or 4 and 3? Not when they're both the same sign. And because it's product sum, we just take what's the variable in front, x. Do we have a variable on the back? No, so we don't have any variable on the back. And we put our numbers, plus 3, plus 4. And you should be able to FOIL that backwards and see if you get the original equation. If you don't, if you FOILed this back and you didn't get this, you made a mistake, okay? You should be able to work back. This is just a simplified version. Okay, what about this one? What times what equals 1 times negative 15? So it's always the first times the last. So negative 15. What plus what equals negative 2? The only way I can get a negative when I multiply is if one sign is positive and one sign is negative, right? To get a negative 15 or a negative anything, I need a positive and a negative sign. Now it matters which numbers we put in what blank, because I need to get a negative 2 ultimately. So my bigger number is going to have to be negative if I need a negative 2. Yeah. Yeah, 5 and 3. So which one's negative? Yeah. So it doesn't matter if you put them in wrong. You'll catch yourself, because if I put in 3 and 5 like this, I go 3 times negative 5 is negative 15. And then I go 3 plus negative 5 is negative 2. But if you put them in wrong, you'd have 5 plus negative 3, which is positive 2, and you'd catch yourself. So if you're someone who's, and you guys are still new to factoring, you only started it last year. It's not like you're going to be pros at it. And you've also haven't done math in a while. So please write these out. Less mistakes happen when you actually write out. I know it takes a little bit of extra time, but you'll get it right every time this way. Okay? Because you can check them. 3 times negative 5, negative 15. 3 plus negative 5, negative 2. And because there's a plus 1 in front, I can just put the x in front. If I had a y squared at the back, guys, you would put a y at the back, right? That was from last year. But I don't have a y squared at the back, so I don't have a number or a variable at the back. I just fill in my numbers. Plus 3 minus 5. I could go x minus 5, x plus 3. Because they're multiplied, it doesn't matter which order they're in, but it does matter that the 3 has to be positive and the 5 has to be negative. Okay? So product sum is when you have that 1 in front. And then you can just do go right ahead to the 2 brackets. But this one here, I do not have a 1 in front. And the only way I get a 1 is if I could take a 6 out of all of them. Can I? No. But I always check first if I can take out a GCF, because sometimes it'll reduce you from trying to figure out factors of 120, and then you take a 10 out to factors of 12, which is a lot easier, right? So GCFs actually just make life a little bit easier if you remember to take them out. This one I can't. So I say to myself, what times what equals 6 times 3? So positive 18. What plus what equals 11? Now I know I need a positive 18, so my signs have to be either plus plus or minus minus, right? I need a positive 11, so minus minus is not going to get me a positive 11 when I add them. So it's going to have to be plus plus. Now I figure out that 9 times 2 is 18. 9 plus 2 is 11. So I know it's 9 and 2. Now where do you guys error? You instantly write x plus 9, x plus 2. You can't do that. There's not a 1 in front. Okay? Now, what you have to do is you have to replace the middle term. If you don't remember decomp, this is why you do this. It's not just replace the middle term with this because it's fun. What you have found is 9 plus 2 is 11, right? So technically what I can do is I can replace this middle term, 11x, with 9x and 2x, right? Because 9x plus 2x is 11x, correct? That's all I'm doing. I'm just replacing that middle term, which is 11x, with 9x plus 2x, because that is 11x. And then I get 4 terms and I can do grouping, which is a factoring way that you guys learned first in grade 10. And you learned grouping because grouping lends you to be able to do decomp. Often you're not grouping by factoring often. That's not what happens. But they teach you that first in grade 10 because it's a step in decomp. Okay? Grouping is a step in decomp. So we're replacing this middle term only with 9x plus 2x because 9x plus 2x is 11x, right? I'm not changing it. I'm just making it a little bit bigger. I'm making it a little more complicated. By making it more complicated, I can group my first two terms and I can group my back two terms. Now, does it matter if I put the 9 or the 2 first? Absolutely not. It doesn't matter. Some just are easier if you do the math on them. That's all. I'm going to choose to put the 2 first and the 9 second because I like 2 with 6 better and I like 9 with 3 better. But if you put them the other way, you're not wrong. Okay? So I rewrite 6x squared, and then I said I'm going to put the 2 first. So plus 2x plus 9x plus 3. So literally all I did was I took 11x and I replaced it with 2x plus 9x, which is 11x, right? That's all you're doing. That's what decomp is. You're not just replacing middle terms for fun. That's why you're doing it, okay? I need people to understand why, because if not, they just do steps and they forget steps. Steps are good, but if all you're doing is memorizing steps, you get to a test and you get scared and you blank, and it's not good, okay? So we're replacing this middle term here. Then we group. And that's the reason why we replace the middle term with 2 terms, so that the front term has a term to go with it, and the back term has a term to go with it, okay? Now I say to myself, what can I take out of 6x and 2x? 2 and x. Now 6x squared divided by 2x, I'm left with 3 and x. Now 2x divided by 2x doesn't just evaporate. It doesn't just go poof and gone. If I said, what's 3 divided by 3? You tell me 1. If I say, what's 20 divided by 20? You tell me 1. If I say 2x divided by 2x, you tell me 0. It's the same rule. 2x divided by 2x is still 1, okay? You have to remember to write that plus 1. People forget to do that all the time. Now remember with decomp, remember you're trying to take something out of the next set of brackets that's going to match what's in left, and get what's left in the bracket. Wow, that was hard to say. So what can I take out of here? A 3. And then 9x divided by 3, 3x. 3 divided by 3 plus 1. If when you take something out of here, these don't match, you probably picked the wrong numbers, or maybe you just oopsied when you divided at the beginning, okay? Now, why do we just write a 3x plus 1 in front? People say, well, because they have told so. Well, the reason why you actually write a 3x plus 1 in front is this is one term here, correct? And this is another term because they're connected by multiplication signs, okay? What's common to this term and this term? What can I take out of both of them? A 3x plus 1. That's why you take it out. This one has a 3x plus 1. This one has a 3x plus 1. So I can take a 3x plus 1 out of both of them. A GCF of 3x plus 1. Now when I take those out, what's left behind? 2x plus 3. So that's why you write 2x plus 3. And that's why you do all the steps in decomp. Not just memorizing, but that's why. Does that make sense? Okay, you guys try the next one. So the first thing we ask is, can we take out a GCF? Because possibly could we turn this to product sum? Because life would be easier if it was product sum, right? No. So we're left with what we have. We have to do decomp. So we go what times what equals 3 times negative 4, which is negative 12. What plus what equals negative 4. So I know it's a negative 12. I know it's a negative 12, so I know one needs to be negative, one needs to be positive, because that is the only way I can multiply two numbers and get a negative number, right? Okay, so I say to myself, what multiplies to give me negative 12 and adds to give me negative 4? Yeah. Negative 6 and positive 2. We know it's 6 and 2. Which one has to be negative? Well, the one that, if this is negative 4, the bigger one has to be negative. If this is positive 4, the bigger one has to be positive. That's just how it works. If you guess wrong, you'll catch it if you check it. So let's check and see. Negative 6 times positive 2, negative 12. Negative 6 plus positive 2, negative 4. We know we're right. So we rewrite our first term, 3x squared. We replace our middle term with this. Does it matter which one you do first? No, and I'm going to prove that it doesn't, because you probably picked 6 to go with the 3 and 2 to go with the 4 because it's nicer. I'm going to use the opposite to prove that it doesn't matter. So if I put plus 2x first, don't change yours. You should get the same answer. Plus 2x first, minus 6x minus 4. So I'm picking the numbers to go with the other number that isn't as pretty. But I'm going to prove to you that you can get the same answer. It doesn't matter. Okay? So all I can pull out of the first one now is just an x. And I'm left with 3x plus 2. All I can pull out of the back is 2. Now, if you pull out a positive 2, you're actually left with negative 3x minus 2, which doesn't match it. So I actually pull out a negative 2, right? Take out a negative 2, and then I'm left with 3x plus 2. Now, what can I take out of here and out of here that's common? 3x plus 2. If you had done it the other way, what would be common? X minus 2. It doesn't matter. It doesn't change the game. So don't spend 17 years trying to figure out which one is better to go with which. Okay? Sometimes it's easier, but it doesn't change it. So we're left with 3x plus 2 we can take out of both. And then x minus 2. Now these are difference of squares. They're difference of squares because the first term and the last term are perfect squares, which means I can take the square root of them and I don't get a decimal. Okay? And they're difference because I have a minus sign in between them. What's the one that people forget is a difference of squares is 1. Often people don't spot the 1. Square root of 1 is 1, so it is a difference of squares. You can use the 1. Square root of x squared is x. Square root of 81 is 9. Square root of 4x squared is 2x. So they work out to something nice. If it was 3x squared plus 4, 3x squared, when I take the root of 3x squared, it's a decimal x. That doesn't work. Wouldn't be a difference of squares then. Okay, has to have two terms. So I say square root of x squared is x. Square root of 81, 9. I get myself two brackets. X goes in the front, 9 goes in the back. And in order to not get a middle term, I have to use opposite signs. If I use plus, plus, or if I used minus, minus, I would get myself a middle term, which would cause me to have 3 terms instead of 2. So that's 2. So that's why we use opposite signs. Because when we FOIL this out, positive 9x minus 9x, they cancel. But if I use the same sign, I'd either get positive 18x or minus 18x, which would give me a middle term that didn't exist. Okay? Let's try this one out. Root of 4x squared is 2x. Root of 1 is 1. So I'm going to get 2x in the front of my brackets. 1 in the back of my brackets. And positive, negative, or negative, positive. The only thing that matters is that it has to be opposite sign. Now this next one looks ridiculously overwhelming. It is not. Okay? Let's make it be not so bad. What do you notice here? N plus 3, M plus 3. They're common, right? Well, how about for now, we just replace them with x's. So we're going to say over here, x actually equals n plus 3. We're going to take those ugly looking nasty n plus 3's out, and we're going to replace them with x's. So now I have negative 2x squared plus 12x plus 14. Life isn't nearly as bad at this point. I can take out a negative 2. Take out a negative 2. And then I'm left with x squared minus 6x minus 7. And now I have product sum. All you do with this negative 2 is it travels down with it. And because this is product sum, I get 2 brackets. Okay? Because it's product sum, I just get 2 brackets. I don't even have to decomp. If you have a phone out, make sure it's away because I can see you texting on it. Okay. If you have x squared minus 6x minus 7, you say, what times what equals negative 7? Whoa. No. No. Okay. What times what equals negative 7? What plus what equals negative 6? So because it's negative, you're going to get negative positive. And you need negative 6, so it's going to be negative 7 positive 1. And all we're going to get then is x minus 7, x plus 1. And everyone boxes this and then moves on. However, you have to remember, it didn't start out as x. It started out as n plus 3. So once you have it factored nicely with all the x's, now you go back and replace your x's back with n plus 3, because that's what they actually were before. So you just go negative 2, and in for x, I'm going to put n plus 3. And then the minus 7 still stays. And then in for x here, I'm going to put n plus 3, and the positive 1 still stays. And then just simplify inside the brackets. Collect like terms. So n stays, and then plus 3 minus 7 is minus 4. N stays, plus 3 plus 1, plus 4. Done. Yeah. The positive 1? From when you factored them up here. Because what times what gave me negative 7, what plus what gave me negative 6? A negative 7 and a positive 1. Now the next one is just a difference of squares. I know 0.25 doesn't scream difference of squares, but think about it. If something is squared on both sides, it should hint that maybe it is. So I'm going to replace, can I replace those? X minus 2, y minus 4? You can replace them with x's and y's if you want. You can. So if you want to, I could replace this with x and this with x with that x because they were the same, correct? If I wanted to, I could go off to the side and say, I'm going to let x minus 2 be m. And I'm going to let y minus 4 be n. If you want to. Or you could just work with them. When you work with them, it completely confuses people. I'm not making them be x and y because then it gets confused because they're already x's and y's. So I'm making them be m's and n's. So I'm going to go 4m squared minus 0.25 n squared. Then there are difference of squares. Cole would know. So Cole, what do we do? Well, look, 4m squared. How do we, when we root it, what do we get? 2 and m. Now when we take 0.25 and we root it, what do you get? Put it in your calculator. Go square root 0.25. So everyone should be punching square root of 0.2. Pardon? 0.15? Pardon? There you go. 0.5? Oh, it's back. Okay. So n, right? So now in the front of the bracket, we're going to get 2m. In the back of the bracket, we're going to get 0.5n. And then we put positive and negative. Now, what's our last step when we do this replacing thing? Is we have to go back and replace them back in. So 2, and then we're going to replace back in m with x minus 2 in brackets. Plus 0.5 and n. Oh, goodness. What is n? N was y minus 4. In brackets. Because when you substitute in, you have to put in brackets because that 2 distributes to both and the 0.5 distributes to both. Yeah. In a second. And then you get 2 times x minus 2 minus 0.5 times y minus 4. And we distribute 2 times x, 2x. 2 times negative 2, negative 4. Plus 0.5 times y, 0.5y. Half of negative 4, negative 2. 2 times x, 2x. 2 times negative 2, negative 4. Negative 0.5 times y, negative 0.5y. Negative 0.5 times negative 4, positive 2. And then collect like terms in the brackets. So I'm going to get 2x plus 0.5y, negative 4 minus 2, negative 6. 2x minus 0.5y, negative 4 plus 2, negative 2. Done. This is your homework. You have about 10 minutes. What? Your homework, you have 10 minutes.